So in this video, I'm going to talk about the differences between scientific laws and theories. And chances are you've studied these in class before. However, I think really until I was teaching this subject, I don't think I really understood the difference between them, the way the textbooks talk about them. So you're going to have some notes on page 13 in your red packet. So if you follow along, you'll find some places where you're obviously filling in some blanks based on the PowerPoints that I have. So let's start at the beginning. Why do scientists experiment? Because we have a natural need to understand how things work and why. So we're going to learn about theories and laws and hypotheses and how each are different and how each interacts with the other in science. So inquiring minds, scientific inquiry refers to the different ways scientists study or observe the natural world and offer explanations based on the evidence that they gather. When we experiment, we start by making observations and inferences. And we'll talk a lot more about the difference between an observation and an inference later on. But we then develop a scientific explanation or hypothesis that will predict the outcome of our experiment. A hypothesis can be supported or refuted through repeated experimentation. So let's look at the example of gravity. When Newton first developed his idea of gravity, he based it on his observations of an apple falling from a tree towards the earth, although we're not really sure that the apple truly hit him on the head. But he hypothesized that an unknown force was pulling the object toward the earth. And he stated, why should it not go sideways or upwards, but constantly towards the earth's center? Assuredly, their reason is that the earth draws it. There must be a drawing power in matter. So if matter thus draws matter, it must be in proportion of its quantity. Therefore, the apple draws the earth as well as the earth draws the apple. So a law is created when a pattern or event in nature remains consistent despite endless testing. So a law explains what will happen, but not why the event occurs. It can be expressed as an equation or a mathematical formula that holds true under specific conditions. And if new observations do not follow the law can be refuted or rejected. So the most important takeaways on this are that laws describe what happens. If you see an equation, it's definitely going to be a law. And eventually, as time goes on, if somebody describes something new that doesn't follow the law that has been believed for a long period of time, the law can be changed or refuted or rejected. This is a scientific law. So in Newton's test, various objects were shown to fall to the earth at the same rate. Newton was able to predict his results using mathematical formulas that demonstrated exactly what would happen each time an object was dropped. However, the question remained, why? Why is it that objects fall to the earth at this same rate of acceleration? So now we start thinking about theories. So hypotheses have to be tested many, many, many times to see patterns in the data and the results. If the observed patterns are consistent, then the idea may gain enough support to be widely accepted by scientists. At this point, the idea may be considered a theory. Theories explain the why of observed events, unlike laws which explain what happens. Theories do not ever become laws because theories explain why, laws describe what. So let's get back to gravity. After all his research, Newton came up with a theory of universal gravitation, which states that gravity acts on all matter in the same manner. He also stated that objects attract other objects based on their masses relative to the distance that exists between them. And this theory was widely accepted as the reason behind the behavior of gravity until 1915, when Albert Einstein developed the theory of special relativity. And in a nutshell, his theory states that all objects in the universe are moving relative to one another, and space exists in 4 dimensions called the space-time continuum. And gravity is the result of large objects warping the space-time continuum and exerting force on the smaller objects in the vicinity of the warp. And yeah, my brain kind of hurts after thinking about all that. So while Newton's laws are still very much tried and true, and we're actually going to study Newton's laws starting in the next chapter, his overall theory of the behavior of gravity has been disproven by Einstein's new theory of relativity. It doesn't necessarily mean that his ideas are wrong. It just means that Einstein's explanation gained more support and got promoted over Newton's to become the accepted theory. And even though Einstein's idea may have won out, it still doesn't explain the behavior of gravity on atomic particles, which brings us to our next point. Theories can be disproven or change over time. So I'm hoping that you gathered the idea that laws are different than theories, and laws describe what happens, whereas theories describe why those things happen. And probably the easiest way that students keep these straight is that they look at the word law, and it ends in W, and that goes with the what. And theory ends in Y, which is like the word why. So looking at those 2 words, that's how most students tend to keep them straight. So I want to look at a couple of examples on this sheet and go through the 5 examples here and then have you do some additional practice on your own. So F equals ma. And do you think that might be a theory or a law? Well, if you look at your notes on the law, we saw that anything that can be expressed as a mathematical equation is going to be a law. So number 1, F equals ma is a law. Letter B, the universe began almost 14 billion years ago with a massive expansion event. At the time, the universe was confined to a single point encompassing all of the universe's matter. That original movement continues today as the universe keeps expanding outward. Well, do you think this describes what happened 14 billion years ago, or does it tend to describe why it happened? Well, it's more of why it happened, because it is this, how it began with this massive expansion event, and it is a theory. And it is known as the Big Bang Theory, which you've probably heard of. Number 3, well, this is another math equation, so that should be a law. Number 4, an object in motion stays in motion in a straight line unless acted upon by an outside force. An object at rest stays at rest unless acted upon by an outside force. Well, this is not describing why something stays in motion. This just says that it does. So this is definitely a what, and this is a law. And then number 5, evolution through natural selection accounts for the tremendous diversity of life on Earth. So why is there a lot of diversity of life on Earth? Because there's evolution through natural selection. So that makes that a theory. So that is also the theory of evolution. So what I typically do now is I have some practice task cards for you to do and collaborate with classmates, whoever might be at the same point. But since I'm not exactly sure how this is going to work I'm also going to put this as a worksheet in the red packet. So it will end up being page 14 in the red packet. So I'm going to put those questions in there, which I have not done as I've videoed this, but I will do that. In addition, I'd like you to answer one question in your textbook, which is question 27 in chapter 1. And once you've gone through those, I will also go over the answer key, and then you can take the assessment.